Hi, so today I'm going to be demonstrating how to draw ClO3 minus's loose dot structure as well as its other properties. So, the first favorite essential atom, and essential atoms is usually the least electronegative atom between the two elements. So, comparing Cl and oxygen, Cl is less electronegative. You know that Cl is our essential atom, and then it's going to be bonded with the oxygen. So, first off, to start off, that Cl does have seven valence electrons, with oxygen having 6 valence electrons. So you're going to first start off bonding the oxygen, and initially when you start dot structures, you want to draw all your valence electrons of every single atom. So first off, usually when you're doing loose dot structures, you first do the sigma bonds only, and only sigma bonds, just to see if it's going to create an octet. So bonding on the oxygen, since they have 6 valence electrons, it means they're going to have two pairs of bonded atoms and then 2 pairs of unpaired electrons. So notice that there are seven electrons right here, another 7 right here, and then 7 right here that are completely bonded. But we want octets and when we're bonding atoms. So given that you have one unpaired electron over here on oxygen, and you have another unpaired electron right here on oxygen. So given this, and since you have a valence electron right here on chlorine and on this side, you can double bond. So this is going to create a pi bond, and you're allowed to do this once you have all of your sigma bonds figured out. So we're going to create a pi bond right here, and then now we have two double bonds between oxygen. Now you're wondering, what are we going to do about this one since it only has 7? Well, since ClO3 minus is an anion, you're going to be adding an electron. So you add an electron right here. If you add an electron to this side, it's going to become bonded now. So that's paired, and since this one's bonded with chlorine, oxygen now has an octet, and now it has a formal charge of -1 since the compound is an anion. So now, given that you have all the oxygens bonded, and then you also have chlorine bonded, and the chlorine has an octet, what are you going to do with these two? So these two electrons are going to form a lone pair. With the loose dot structures, I've drawn out the resonance structures. So resonance structures basically mean that you can kind of move the pi bonds interchangeably and kind of shift it towards another side. So now that we've done the electron dot structure, and I'm going to be talking about the electron pair geometry and also the AB notation and also the molecular geometry. So given that we already figured out that there's 2 pi bonds, 1 sigma bond, and 1 lone pair, you can figure out that the electron pair geometry is going to be AB4 because there are 4 bonds total. And then with the molecular geometry, in the AB notation of AB3E, and the E represents the lone pair, the 1 lone pair, you can figure that the molecular geometry is going to be external pyramidal, and that is going to be because there's 1 lone pair and a derivative of the root shape. And then for the hybridization, since there are 4 bonds, the hybridization is going to be sp3, and for the bond angles, a tetrahedral structure has a bond angle of 109.5 degrees. So with a lone pair, it's going to have a 2.5 degree bend. So then the bond angles are 107 degrees. Also, just for reference, this is the molecular geometry representing using grapes, and then this little chromatin poststem is representing a lone pair. So you have right here 1, 2, 3 bonds, and then you have a lone pair.
So for ClO3 minus, as Khang showed earlier, this is pretty much how the Lewis structure would look for ClO3 minus. As you can see, you have a central atom Cl bonded to 3 oxygen molecules, and then 2 of them will be double bonded, 1 of them will be single bonded because this one will have an electron added to it later. That's why it has a negative charge. But for the bonds, the polarity of these bonds and the kind of dipole moment would be actually pointing towards the oxygens, and this is because the oxygens would be more negative in charge than the Cl, because as you can see, the oxygens would all have -2 charges, whereas the Cl would just have a -1 charge. So because of this, we'll be able to determine that ClO3 minus will have a molecular polarity of just polar, because it has net dipole moments going just away in general from the Cl, meaning it's not symmetrical. And yeah, so that would cause ClO3 minus to be polar. And then in general, molecular geometry and bond polarity are relevant to I guess, the molecular polarity of this structure, because this is, as you can see, a trigonal pyramidal structure. And generally, trigonal pyramidal structures are polar just because you'll have, what's it called, one pair of electrons and then three atoms bonded to the central atom. And then generally these three atoms can't be symmetrical just because they have this one lone pair that doesn't allow them to be symmetrical with similar bond angles. So yeah, that's how the bond polarity and molecular geometry kind of affect the overall molecular polarity of this structure. Thank you.